And here we go, Caitlin and Reed. All right. Anyone else come in since I called up? Okay. Okay. Let's find the current slide. And okay. We'll start example 11 here, but we'll come back to that. Let me first make a few announcements. Now, where to begin? I guess, why was all the chaos when y'all were out in the hall, okay? Because y'all were out in the hall making a lot of noise. No, that was it. Why I wasn't in the room down there like I usually am, someone stole the projector from the ceiling in that room. That's the second projector stolen in the last week or two here at the college, here at this campus. Now, a few years ago, someone went through the B building and took everyone out. The room wasn't locked in one fell swoop, I think over a weekend or something. But this has been done piecemeal, and it's been done in broad daylight. Sometime in the afternoon, it seems like, before 6 o'clock, probably sometime afternoon. Bizarre, okay? If you know anything, please let someone know, because it's costing you, it's costing us. This one, I, knock on wood, think is fairly safe because it's mounted differently from those, but they still may get it. But you may not start noticing this. The security is not unlocking rooms now until the instructor is present, which means that people will be standing out in the hall a lot. Now, that's not why y'all were in the hall this time. It's because I was returning papers, and those people were coming in so late. Every time I start to return papers, someone else would come in and need to do a test, so I couldn't return the papers. So I had to wait till the very end of the class to return papers to them. We can do that here too, but I can return them now. We'll get to that in a minute. But anyway, this is our last class, so it won't affect. Are most of you coming in the summer or not? Okay, you are? Good. They may still have that in place, having doors locked until instructors show up. Just get ready to stand in the hall. I see y'all having to stand out in the hall some anyway, so get used to it. Okay. I'll try to be here and get doors unlocked that I can, but security will not, they say. Okay. They may change their minds. But, and I had students, because I couldn't get to another classroom to let them make up tests, they were in offices that I could get to. There was a class next door, so they couldn't get there. So it was chaotic the whole time. All right, so there's that. Let's then talk about how the term's going to wind down. This is our last day of class. I do want to ask this question. I hope I've asked it before, hopefully several times, but I may have forgotten. Have you done the student course evaluations? Yes? Good. If not, please do those. Now, if you don't remember how to do student course evaluations, do you check your Lawson email ever? Okay? Check your Lawson email, and sometime in the last, 3 or 4 weeks? That long ago, you think?
Something like that.
Yeah, something like that. 2, 3, 4 weeks, something like that. They send out an email to all students with a link that you click on the link, you go right to the student course evaluations. Please do those. That is our best way of documenting that we have feedback from you. It's my best way of finding information. Okay, you need test 2. Okay. Okay, you don't want the trig final exam? No, okay. Just checking. Okay. See, she was willing to take it for one of you guys, but no. Why did Quinn Q leave this with me? Oh, she may not have come pick it up. That's it. Okay. Here's test 2. Do you need graph paper? Huh?
I already got some.
You got some. Okay. All right. Unfortunately, it may be like that all day. I don't know. about to say how we're going to finish the term? Okay. Today's the last day of class. We're going to cover materials as far as we can today. I will return papers to you. You want them first or you want them at the end of class? At the first? Okay, you want to get it and go. Is that what you say? No, you wouldn't say that. Okay. Now, here's the time for a really sad song. Okay? Because I had so many papers turned in so late yesterday, I did not have time because I had classes all day, had 2 hours in the morning, and that was eaten up by a variety of administrative details. And then I had no office hours for the rest of the day. And then finally, last night I graded, but they had turned in so many papers late, I didn't have time to get to yours. So anything that was turned in to me Tuesday, I don't have graded. Anything before Tuesday, I do. So here's test 1. Test 1. Ryan's not here yet.
Real sad song when you pass out test 3.
What's that?
So it's going to be a real sad song when you pass out my test 3.
Okay. No. Okay. Jeremiah has come and gone. Christian. Okay. Jonah. Bree. Cody's not here. Ariel. Lindsay's not here. Stephanie. That's 1. Seth. 7. All right. Test 2. Not here. Issue. Well, I can't guarantee it'll be graded because it's so late getting it, but I'll get it as graded as soon as I can. Breathe. Baby's not here. Ariel. Okay. Test 3. Okay. 2. Ariel. 7. Okay. And I think, unfortunately, that's all I've got graded. Any that were turned in Tuesday or recently, I just didn't get to. It's been hectic, worse than hectic. And at the same time, I've been trying to get fall schedule done because that is a total mess. So sorry about it, folks. So with that in mind, let me go over when and how and stuff you can pick up the rest of your stuff. Today I'm in class until basically 5:45 this evening. I've got a 15-minute break here, a 30-minute break there, and that's it, okay, until 5:45. I'll have a 15-minute break then if you want to catch me then. And I'll be here after 6 o'clock, so I'll be here for a while after 5:45. Okay, today's Thursday. Tomorrow, Friday, I'm on the Birmingham West Campus in the academic building. That's the B building, room 120, B122. That's Dr. Pruitt's office suite. And I'm in the copy room behind the secretary's desk. Her name's Rose Saxon. Her name's Dr. Pruitt's name's on the door. But come on in, and if I've got some things graded, I can give them to you then. Okay, so that's tomorrow. Monday, we have class. They published the final exam schedule incorrectly and put Monday was the finals day. It's really supposed to be a class day. So I'm in class on Monday, but I am in the office from 8 to 10 and from 3:45 till 6. So I'll be in the office Monday, 8 to 10, and basically 4 to 6, okay? I'll be in class pretty much from 10 o'clock until 3:45. I have a 45-minute break for lunch and a 20-minute break between the next two classes. But other than that, I'm in class from 10 till 4, basically. Now, Tuesday, I have a final exam, 8 to 10. Now, if y'all haven't noticed this yet, on the final exams, we went this year, first year ever, that we went to 8:30 classes, starting class at 8:30. But they kept the final exam schedule starting at 8 o'clock. So don't let that sneak up and bite you. Your finals are scheduled for 8 o'clock on Monday and Wednesday. They're 8 o'clock, 10 o'clock, blah, blah, blah. And Tuesdays and Thursdays, they're 9 o'clock, 11 o'clock, and blah, blah, blah. Okay? So please note that. So anyway, I have a final Tuesday morning from 8 till 10, basically. It'll be down in 205. I don't need a projector to give the final, so I'll be down there then. Technically, your final may be due on Tuesday. I'm going to give you that before you leave today. But you can get it to me anytime next week. Now, here's a very important question. Are any of you graduating this term? 1, 2, 3, 4. Okay, 4 people graduating this term. I have to have your test 4 and final exams in by Thursday. If you can get them to me sooner, fine. If you can get me one sooner and then one later, that's fine. But get everything in to me by Thursday, because your grades have to be in by noon on Friday. Noon on Friday. No choice there. Otherwise, you may not be graduating. So please get those to me sometime Thursday or sooner. The rest of you, anytime through Monday of the following week will do fine. The sooner the better, okay? The sooner you can get them to me, the easier it is to get everything graded. Your grades don't have to be in until noon on Wednesday of the following week. So we got more time for you, but for you graduates, you got to get them to me by Thursday. Yes? Okay, yeah, I'm getting there. Okay, so just a second. What did I get up to Tuesday? I have an 8 to 10 final on Tuesday. Then for the rest of the day, well, from 10 o'clock until 1:15, I'll be in my office on Tuesday. 1:15, I have a second mini-term class. Their classes aren't over with until later. So we have a class on Tuesday at 1:15. Now, it probably won't go till 5:45 like it usually does, because we won't have that much to do. We're basically wrapping things up. So whenever we finish after that, I'll be back in my office. That's on Tuesday. Wednesday, I have no scheduled final exams, so I should be in my office from 8 to 4. 8 to 4 on Wednesday. At 4 o'clock, I leave to go to the Birmingham East Campus, and there I'll be from 4:30 to 6:30, because that's when they'll be turning in their finals. Okay? So that's Wednesday. Thursday, what you're asking about. I have no final, wait, I do have a final scheduled at 1:15, or 1 o'clock, let's say, at 1 o'clock. It's not going to be a very long final, so most of the day, from 8 to 1, I'll be in my office. After 1 o'clock, I'll be up here until they've all finished their finals. Then after that, I'll be back in my office until 6 o'clock. So basically, I'll be in my office from 8 to 6, except for that 1 o'clock final, which I don't think will last 2 hours. Almost certain it won't, but allow 2 hours there. You can find me up here if you need to. Okay, Friday, I'll be back on the Birmingham West Campus, Dr. Pruitt's office, B122. 8 to 12 on Fridays, tomorrow and next Friday. So I'm usually there before 8 and almost always there after 12. Okay. Monday, that's technically the last day of finals. I don't have any scheduled. I'll be in my office from 8 till 6. 8 till 6 on Monday. So that's the last day to get things in, get them into it. Now, let me say this. Your research papers, I've gotten several in today. I haven't been able to keep up with who's turning them in and who hasn't. But if you haven't got me a research paper yet, if I don't get it today, you start losing points. I will accept it later, but you will be losing points. So please get me your research papers today if possible. If not, get them to me, but you'll be losing points. But I can't accept them past Monday of the following week. Not next Monday, but the following week. Okay? And that's when I'll be wrapping everything up and trying to get all the grades in. We'll be here on Tuesday. I'll be here 8 to 6 on Tuesday. On Wednesday, I'll be here 8 to 6. I have to have grades in by noon, but I'll be here in my office basically. Thursday, I can't remember how many duty days we have, but we have a bunch of duty days. We'll be here. Okay, I'll be here 8 till 6 every day until they say, I'll have to look it up and see. So many duty days. And then graduation, y'all know, is Friday afternoon, right? 1 o'clock? 1 o'clock in the gym on the Birmingham West Campus. So Friday, I'll be over on the Birmingham West Campus 8 to 12, and then at graduation until it's over. And then I'll be going home. Okay. I think that's all the duty days we have. Okay. So, any questions about my schedule or when you can get things in? Okay? Good deal. Now, let me see. I think a few people came in since I marked the roll, so let me make sure I've got you accounted for. I got Caton. Cerinthia's not here. I've got Jake. Ryan's not here. I've got everybody down to Cody. He's not here. Demetric's not here. Lindsay's not here. I didn't get Stephanie. She came in. And I didn't get Devin. I don't think when he came in. Yes. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2, 4, 6, 8, 10, 11, and Jemiah is 12. She came and had to leave. She has and she said an aunt or somebody was having surgery today, I believe, or something like that. So she had to go. All right. Any questions before we get going? Administrative? Yes. I'm sorry, I can't hear you.
Can I get my test?
Okay. Yeah. Are you leaving? Oh, okay. Okay, I got you everything you had turned in before this back, right? Okay. So I won't have to say it too many times again. The final is really just one part, but I'm giving you 2 tests. I've just got to find it first. Okay. Okay, here it is. Okay, let me explain this to everybody while I've got it here in front of me. Okay, before you leave today, there will be a test. Now, unfortunately, I didn't get it marked correctly on the thing. It's test 4. It says test 3 at the top, but it's test 4. 1 page, that's chapter 6 test. Then the final exam, these are each 10 questions each. This is your comprehensive, and you got, I can't remember, something like, let's see. I think the first 6 questions from chapter 4, 2 from chapter 5, and 2 from chapter 6. Okay? So that's your final exam.
Are we doing all of them on chapter 6?
What's that?
Are we doing all 10 on the chapter 6?
On the first test?
Yeah.
Yeah. Those are all on chapter 6. That's why I only gave you 2 on the final. Okay. All right. Good deal. Any questions on that? I'll answer them again when I give you yours.
I got a question on topic.
Too late. No, what?
What is the last day you can apply for online summer classes? Do you know?
You can. Okay. That's really a good question. It's going to be tough to answer.
said
registration for summer classes are currently open. People are registering. And you can register right up until the first day of class and possibly even 1 or 2 days after when they have drop ad. Okay? After that, registration is closed. So you've got time. Technically. Okay? Realistically, I've helped some students register last week, only 1 or 2 this week, during my office hours when I'm trying to grade papers. But those that have registered for online classes that I've helped register, those classes were filling fast. So even though technically you can wait until then, you may find the classes are already closed then. So I would say do it as soon as you think you may be coming, go on and do register for online. Okay? Because when I last looked, I have one student registered for like 2 online classes, and one was within 2 or 3 of being full, and the other was like 3 or 4 to be full. So they were both really getting close. And this was probably last week. So, yeah.
Okay.
All right. All right. Good question. Does that adequately answer it? Okay. All right. All right. Any other questions? On or off topic? Okay. Okay. Anything will work. Let's do example 11 that is on page 424, the last example in 6.3. Using vectors to find speed and direction. Okay, let me get my pen set up. Okay. All right, this is example 11, top of page 424 in section 6.3. Thank you. Okay. Crazy all day long. All right. An airplane travels at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with negligible wind velocity as shown in the figure in your text. So I'm going to do my poor rendition of what they are talking about. I think everything stays above the in the top 2 quadrants, so I'll keep it here. 500 miles per hour with a bearing of 330. Well, 330, now if you remember bearings do not go the same way that angles go. Angles start on the positive x-axis and go counterclockwise. Bearings start due north and go clockwise. Okay? So a bearing of 330 is going to be 30 degrees shy of 360. So there is the bearing of the plane, and let's say this is a 500 miles per hour vector. Okay? 500 miles per hour is the magnitude at a bearing of 330. A fixed altitude with negligible wind resistance. Okay? A bearing of 330 corresponds to a direction angle of 120. Okay? Direction angle being there's 90 and 30 is 120. That's what we're talking about there. Okay. Now, the airplane encounters wind with a velocity of 70 miles per hour in the direction north 45 east. So, aim like you were going north, then do 45 degrees to the east. Okay? So this is 45 degrees to the east, and that's a velocity of 70. So this is the wind velocity. This is V of plane, and this is V of wind, and that is 70 miles per hour. Okay? And my vector, I can guarantee you, is not to scale. Okay? Guaranteed. Okay. North 45 east. Shown in the figure.
That's 70 miles per hour, you said?
70, yes. I believe that's right. I'm making fun of my writing, I can tell, but I'm not at all hurt by it. I'm used to it, sort of. Okay. What is the resultant speed and true direction of the airplane once that wind kicks in? Okay? Well, hopefully you've gathered this so far, the best way to do these kinds of problems is by components. Okay? So let's break down the airplane's velocity into a horizontal component and a vertical component. Now this we know is the angle 30 degrees. We know that. What would this angle be? 60. Excellent. Okay. So we know that the plane's velocity, now I'm used to calling it X and Y. Since you're dealing with directions, you could say east and west. What do you want to call it? East, west, north, south, X, Y. What do you want to call it? Second? X and Y. So we'll call this, you know the hypotenuse here is 500 miles per hour. That's the magnitude of that vector. Here is the horizontal component of that, or the X component of that, and that would be here. How does that relate either to your 60 or 30? I don't care. I'll just assume use 60, but you can use 30 if you want to. How would that relate? Here you have an angle, hypotenuse. Say again?
You do sine 60. You do the sine of 60.
Did you sine? Is that what you said? Okay, sine 60 is the opposite. Cosine 60, or you could have thought of that in terms of sine of 30, because this would be your 30 degrees up here too, right? And what is the sine of 30 degrees or the cosine of 60 degrees? Oh, one of our favorites. What value? Cosine 60 or sine of 30 is? We've had them for all term. What's that value? Second? 1/2. So 1/2 of this, so that half of 500 would be 250. So that's our, and it's a minus 250 if we're doing XY. So your VPX is going to be minus 250 miles per hour if you want to put units with it. Okay, I'll put them miles per hour. Okay? What would be your vertical component of your plane's velocity? VP, I'll call it Y. What will that be? And you can leave radicals in there if you want to. Anyone remember what that was? Please say yes. That would then be the sine of 60 or the cosine of 30, either one. What's that? Oh, we finished that chapter. We don't need to know that anymore, do we? Anybody? Root 3 over 2. And so this will be 500 times root 3 over 2. Well, that will be 250 times root 3. Okay? I'll clean that up a little bit. Whoa, I didn't want to do that one. No, go back. Okay. Oh, man. Okay. Okay. 250 root 3. Good deal.
I'll be back with my quiz.
Okay, great. Thank you. Yeah, it's all day. Okay. All right, so that's 250 times root 3. That's your Y component. Let's do the X and Y components of our wind. The X component will be here, the Y component there. I'm going to blow this up a little bit so it'll be easier to see. This is your 45 degrees, north 45 east. Oh, this was your north 45 east. What does that make that one? 45 also. Okay. Now what would be your V sub wind X? This, remember, was 70 miles per hour. X component? Help me somebody. Oh, it was was a long time. That's Tuesday. X component, the vector, is related to the adjacent side, which would be the x. What trig function relates adjacent to the hypotenuse? Cosine. What's the cosine of 45? Oh my. And these were our favorites. Root 2 over 2. So it was 70, root 2 over 2. Well, half of 70 is 35. So this would be 35 root 2. And that would be miles per hour. And guess what the V when vertical will be, or Y value? Same thing, 35 root 2, because 45, the sine and cosine are the same, root 2 over 2. So 35 root 2 miles per hour. I won't write it down, I won't have room. So what we do now is add the x components together. Here we have a minus 250. Here we have a positive 35 root 2. So it'll be, goodness gracious, what a mess. I guess we're going to have to do the root 2 at some point, so do it. 250 minus 35 root 2. Someone with a calculator. Punch it in. You think, yeah, I was going to do all the work today, huh? Okay.
You want me to use my calculator?
It's always a fun experience, isn't it?
I got 200.5.
Second?
I got 200.5.
Okay, and that would be in the minus direction. So minus 200.5. 200.5. We'll leave that. Okay, that would be the resultant in the x direction. Resultant in the y direction, that was 250 root 3 plus 35 root 2. 250 root 3 plus 35 root 2. These are both positive. I'll put resultant here, and V sub y resultant is equal to 250 root 3 plus 35 root 2. 482.5. Okay? Now, the question, excuse me. Don't know why that's happening, but I'll wait. Get that. Says, what's the resulting speed? How do we get that? Here is our x component here. Here's a y component there. How do we get resultant speed? That one's in place. How do we get the resultant speed? Pythagorean theorem, of course. So the square root of 200.5 squared plus 482.5 squared is what? Say again?
192.
Whoa, no. 200 squared plus 400 squared is going to be a lot more than 100, the square root of that.
No, I said 192,000.
Okay, and you took a square root already? Oh, okay, take the square root, yeah. Square root of that is?
438.
Whoa, say again?
Yeah, 438.
No. It's got to be longer than either of these two. This squared plus that squared, then take the square root. The minus sign, don't be subtracting anything, because you see when you square that, it becomes positive. That sounds reasonable. Do you, anyone else get it? Say again, 5.
522.5.
Let's make it 523. Okay, 523 miles per hour. Does that make sense? Okay. See, all this, I've been saying, no, that doesn't make sense. Well, this one sort of does. You were going at 500 miles per hour, okay? Your wind is going to be knocking off some from your horizontal component, but not a lot. But it's adding to your vertical component, and since that's a little bit greater there, then I think that, yeah, we should come up with something a little bit greater than 500. And that does make sense. How does the book do? Well, who tells what they do? Oh, no. 522.5 is what they said too. I think someone was reading this book. Okay. So that gives the speed, but it says what's the true direction of the airplane now that you've done all this. Okay? Now, how are we going to do that? The direction of the airplane. Second? Tangent of what?
482.5.
Okay, that's awfully close, but not quite. What's he missing there? It's inverse tangent of that. Okay. Now, if you use this to be your angle, which you could, that's what it sounds like you were doing, you want to call that theta, then the tangent of theta would be exactly what you said, 482.5 divided by 200.5. Okay. Now, I'm going to leave off the negative for now. I'm sorry? Take your test one? Okay. Okay, I think next door is free. Go and look. Do you need graph paper? Okay, hold on just a minute. Let me get the graph paper. I didn't go deep. Well, must be deep enough. Here it is. I think next door is open. If it's not, let me know. Or, second? Yeah, you can. Yeah. Or one of these two officers will work too. Just can't believe you walked into a class in progress. Okay. So, if you're just looking for this angle, let's count this sort of as a reference angle and just use the magnitudes here. So I wouldn't do the other. Otherwise, you're introducing all sorts of bags of worms. We don't like that worms that much. So, your tangent will then be tangent of that. Would be that. You're looking for theta, so then the theta will be the inverse tangent of 482.5 over 200.5. Okay, and see what that gives you. Inverse tangent of that mess.
It's negative 67.44.
Yeah, okay, I think I can see that. This is sort of confusing here, isn't it? Did you plug in a negative angle? Oh, you did?
Not supposed to.
No, I said, let's just use the reference angle here and do the absolute values of those.
Oh, well,
But I think you'll get the same thing. Say again?
67.44.
Okay, theta is equal to 67.44 degrees. Okay, now, that's not a bearing, and how do they answer this? The true direction of the plane. What I would suggest doing is subtracting this from 90, the complement, because you want this angle here, and that would be, I think we can do that fairly easily, can't we? That would be 26.56 degrees. Is that right? I'm doing it in my head, so I may have it wrong. So you can either do north 26.5 west. That would be one way to give the true direction of the airplane. The original gave it in terms of a what did they call it? Bearing. And what you would do then would be subtract this number from 360. And that would give you the same thing. What do they do in the book? Oh, they do that. So let's take this number and subtract it from 360. And that would give you 333.44 degrees. That would be the bearing. Is that what they got? No, 337. Kind of botched something up here. Let's check their things here. 282.5 over 200. $67.44. That's what you said, wasn't it? I must have made a math error somewhere here. Yes, I did. Yeah. Right here, when I was doing this from 90, that certainly isn't right. That's a 2. That would have been a 22, and then this would have been a 7. Okay. Whoops. Did get my eraser.
So you subtracted the angle that we found from 90?
Okay. Okay, right. The angle that we found here, this angle here, theta, we wanted this angle. Okay, so we subtracted from 90. And that's where I botched it. That was a 22.56. For some reason, I had another number there. Okay, then when you subtract that from 360, you get this one. So 337.44. You don't have enough precision there. 337 is fine with me. So a bearing of 337 degrees. So you see he's off a little bit from what he intended to go. Intended to be 330, and he's really 330. Well, the wind. It's a pretty good wind, and it's blowing them a little bit to the right. A little bit north, that's why it increased his wind speed. It's a little bit of a tailwind, not directly, but also it's veering them to the right, so it increased from 330 to 337. Make sense? Okay. No? Okay. I mean, does that sound reasonable? If you're going along here at 330 degrees, okay, at 500 miles per hour, and then you hit a wind that's north and east, that's going to push you a little bit further east, but push you a little bit further up. I thought you were at a game.
No, it got canceled. We were on the way down there. It got canceled.
Oh, really?
We got rained away.
So, where were y'all going?
Marion.
Marion? I guess so. Is the rain coming? Yeah, I guess the rain is coming this way. Yeah. We're supposed to get rain this afternoon. Okay. Glad you're here. All right. Catch me after class, and I'll get your other test back to you. Okay. I don't have them all graded, but I'll give you back what I have got graded. All right. Any questions about this? Does that kind of make sense? Answers feel right anyway? Okay. When I heard a few 100,000, I went, it can't be that, way out of line. And then when I heard something less than 482, no, the hypotenuse can't be less than one of the sides. So those kinds of things keep in mind. Even if you don't give me right answers, make sure they make sense answers, that they're at least in the ballpark, reasonable answers. All right, that did finish 6.3. We didn't do our vocabulary. Let's do that quickly. You can use a blank, blank, blank to represent a quantity that involves both magnitude and direction. A blank, blank, blank. I know a one-word answer. Vector. Well, what's a three-word answer? What is a vector? Directed line segment. Y'all are on top of it, aren't you? Okay. Directed line segment. Okay. That's what they're looking for. Okay, maybe we won't do these. Okay. Look at the first 4 words in the next one. The directed line segment, PQ, has blank point P and blank point Q. Initial point and terminal point. Very good. We're on it now. The set of all directed line segments, there it is again, that are equivalent to a given directed line segment PQ is a blank V in the plane. Vector in the plane. Number 4. 2 vectors, there's that word, are equivalent when they have the same blank and the same blank. As if we haven't been talking about them with this problem.
Direction and magnitude.
Second, direction and magnitude. Perfect, in whichever order you want to. Number 5. The directed line segment whose initial point is the origin is in blank blank. Vector whose initial point is at the origin. That's called standard position. Standard position. Okay? Number 7. No, number 6. The vector. Good deal, thank you. Ryan's here. Wow, we're down to only missing Cerinthia, Demetric, Lindsay. That's it. Good deal. And those who came in late, I've got the tests that I have graded. I haven't gotten them all graded. The ones I have graded, I can return to you before you leave today. Okay, so number 6, this is the vocabulary from 6.3 on page 425. A vector that has magnitude 1 is a blank blank. Unit vector, excellent. Okay, number 7. The 2 basic vector operations are scalar blank and vector blank. Scalar multiplication and vector addition. Very good. And then addition does include subtraction. What's that?
Staple those together. Those are graph.
Okay.
This is the test.
The test. So this graph. Okay. So I'll just put them in here. Is that okay? Put it down. Okay. All right. Number 8. The vector sum v1i plus v2j is a blank blank of the vectors I and j and the scalars v1 and v2 and are the blank and blank components of v respectively. That makes a lot of sense, doesn't it? Okay? What we call that is and if you look on the page immediately to your left, the summary, the what? Linear combination. That's the blank blank. And the V1 and V2 are they may not say it here, but you should know that one. And components of the V respectively. Very good. Homework exercises. I've assigned most of these before. Let's see. Do any of the odds 9 through 13. They're all at Calc Chat. 11's at Calc View. Do any of the odds 15 to 23. They're all at Calc Chat. 19's at Calc View. Do any of the odds 25 to 29. They're all at Calc Chat. 31 to 35. They're at Calc Chat. 31's at Calc View. 37 or 39. They're both at Calc Chat. 37's at Calc View. 41 to 45. They're all at Calc Chat. 43's at Calc View. 47 or 49, both at Calc Chat. 47's at Calc View. 51 or 53, both at Calc Chat. 51's at Calc View. Any of the odd 55 to 59, they're all at Calc Chat. 57's at Calc View. Either 61 or 63, they're both at Calc Chat. 61's at Calc View. Any of the odds 67 to 69, they're all at Calc Chat. 65 to 69, they're all a calc chat. 67 is a calc view. Do 71 is a calc chat. 73 is a calc chat. 75 is a calc chat. Then from there, do any of the odds 77 through 87. They're all at calc chat. Then there's an 89 or 91. They're both at calc chat. And then 93 is at calc chat. True false, 95 and or 97, calc chat. And then there's error analysis. If you want to do that, is 99. There's a proof at 101. And then finding the difference of two vectors, 103. They're all at calc chat. 105 should be at calc chat. 107 is a writing problem. I don't know if it's a calc chat or not. So, with that in mind, let's clear any questions before we move. All right. Ooh. All right, let's get going in. I didn't want to do this. Okay. Chapter 6, Additional Topics in Trigonometry, 6.4, Vectors, which we were covering, and dot products, which we haven't covered yet. Let's try to hit it quickly, okay? And since we don't have much time, I'll skip all this and that. Here is what we mean by the dot product of two vectors. Here's vector u. Now, this is two-dimensional vectors. It'll extend to 3. U is U1, U2, U1, U2, V1, V1, V2, okay? The dot product is the product of the first components, multiply those together, and add that product to the product of the second component. U1, V1, that's times, plus U2 times V2. Guess what? The dot product of two vectors is a scalar, not a vector. Dot product of two vectors is a scalar, okay? Back in the old days, we used to call that a scalar product, but we don't now because we call that A times a vector would be a scalar product, so we call that a scalar product. This is one way you can multiply two vectors together. Multiply a scalar times a vector, that's easy. Just multiply it by each component. Multiply a vector by a vector, there's two ways. One of these is a dot product, which is the product of the sum of the products of their components in the right order, okay? And it doesn't matter what order. You can do V1, V dot U, you get the same answer, okay? You get exactly the same answer. That's the definition of a dot product, okay? So here are some of the properties of a dot product. U, V, and W be vectors in the plane or space, and C be a scalar. Like I just said, it doesn't matter the order. U dot V is the same as V dot U. If you did that by components, you see they come up the same thing. The zero vector dotted with any old vector, any other vector, is going to give you a scalar number 0. Remember, the result of a dot product is a scalar, so that's the scalar 0 here. That is the vector 0 there. Okay? Now, here's one way you can distribute a dot product. Okay? If you distribute the dot product of U across the sum of V and W, well, the sum of V and W is going to be a vector, another vector. Okay? So you can either add those together and then do the dot product of this, which gives you a scalar. Or you could dot the first two together and then add to that the sum of the second two dotted together. That's going to be a scalar, that's going to be a scalar, the sum's going to be a scalar. So you get a scalar anyway. Now here's another pretty interesting true thing. The dot product of the vector with itself is the magnitude of that vector squared. Magnitude is a scalar, and a dot product gives you the magnitude squared. Because you don't take a square root of it. You do the V1 squared. I mean, you multiply those two, that gives you V1 squared plus V2 squared plus V3, whatever. To get the magnitude, you take a square root. Since you're not taking a square root, you get the square of that. Now, here's how you distribute a scalar across the dot product. Okay, a dot product is going to be a scalar number, so you just multiply a scalar times a scalar, which is going to give you a scalar answer. Well, here's one way you can distribute. Cu dotted with V, or U dotted with CV. Notice you don't distribute both, because this isn't distributing. Distributing is with multiplication and addition. this is all multiplication. So you either multiply this by this one and dot it with that, or take the first and multiply it by that, or take this one and multiply it by the dot product. This would be a scalar, that would be a scalar. This is a vector, that's a vector, but the dot product of two vectors is a scalar. Okay. So those are just some of the properties of dot products. Okay? Let's do a few. Unbelievable how easy these are. Oh, wow. Why would they do that? Okay. Really easy if they give you the answer. Okay, how do you do the dot product of those two vectors? These are in component notation, the easiest way to do it. What would that be?
It's going to be, you have to multiply each axis.
Yeah, what do you get? What you get?
It's 4 times 2 and 5 times 3, right?
Yeah.
So it's 12
Who?
and 15.
Who?
8 and 15.
8 and 15 is? 23. All right. Yeah. Okay. 8 and 15 should be 8 and 15, and that should be 23. All right. Like pulling teeth. Okay. Let's do this one. What would that give you? Anybody?
0.
Second?
0.
0, exactly. This will be 2 times 1 is 2. Negative 1 times 2 is negative 2. 2 plus negative 2 is 0. All right, now let me do something for you there. I'm going to do it on the board over here. Let's draw the vector. I'll go to that piece of chalk. Okay. It's probably become ugly. How do I do the first vector? 2, 1. That would be 2 to the right, 1 up. Can y'all see from there? Let me double it. 4 to the right and 2 up, or 6 to the right and 3 up. Can you see that better? 8 to the right, 4 up. Tell me when it's big enough. I can't count them higher or down. I think that's it. I hope that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. Now let's do 1, 2, which is, y'all let me get away with that. It's a -1. I can't read from here. So that's -5 here. Okay. That's that vector. Right? Y'all say right to anything with me, okay? And then 1, 2. What did I do? How many did I do? 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. Now, at least in general, what would you tell me about that angle? What does it look like it might be? It sure does, doesn't it? And indeed it is. Here's a little hint. Should have had on the other set of properties, the dot product of 2 perpendicular vectors is always 0. That's a very useful fact. And these two are perpendicular vectors to each other. Okay, let's do this one. What's that be? Anybody?
-6.
-6. So dot products can be negative. They're just scalar numbers. -6. Very good. See if there's another. Oh, no, there's not. Okay. Now, the angle between two vectors. I'm doing this fairly quickly here. Let's get right to the chase. Okay? There is another definition for a dot product. In fact, I think if I remember right, back when I first learned dot products, so long ago, I could be wrong on this, this was the definition that dot product of two vectors is the magnitude of one times the magnitude of the other times the cosine of the angle in between. Okay? And this is showing you that fact. So if you know two vectors, you know how to do the dot product, you can get the angle of between those two vectors by this formula right here. Dot product divided by the product of their magnitude. That's the cosine of the angle, then do the inverse cosine, you get the angle. So dot products are pretty useful things, okay? They're used in physics a lot, and most of you, I hope, will be taking physics at some point in your life. Maybe some of you won't, huh? But anyway, most of you will. You planning to or not? Don't know yet, okay. Oh, you're not planning to, are you? No. Shame on you, okay. But anyway, I hope the rest of you do. Use dot products a lot there, too. For instance, work is defined as the dot product between the force and the direction of the force, the displacement. Used all the time, okay? All right, do we have time? How much time we got? 1 minute. Let's see if we can do this. Find the angle theta between these two vectors. How would you do that? Can you give that little formula I had? Oh, so long ago. Cosine theta is equal to u dot v divided by the magnitude of u times the magnitude of v. So what three things do we have to know? Dot product, what's it? Oh, I can hear the gears going. Say again? 25? The magnitude? Wait, okay. The dot product. 4 times 3 is? 12 plus, say again? 15 is 27. Okay. So 27 over, oh, this is going to take a little more effort, isn't it? First one shouldn't. Magnitude of the first vector. See, that's what I thought you were answering. Magnitude of the first vector. Oh, somebody help me. Square root of 4 squared plus 3 squared. 25. What's square root of 25? 5. Okay. 5 times. Now that next one's not going to be as nice. 9 plus 25 is 34, root 34. Okay. So you'd have to enter that on your calculator. 25 divided by 5 times root 34. All right, good deal. Thank you. And what we hope will come out a number between, obviously it's going to be positive, so it's going to be between 0 and 1. Did we? Anybody? Nobody? Second? 27 divided by 5 root 30 times root 34. Now, how you enter that, how I would enter is 27 divided by 5 and then divide again by root 34. Okay? Or you could do 27 divided by open parentheses 5 times root 34. Close parentheses.
I got 0.926.
Sounds like a good number, and then take the inverse cosine of that. That gives you cosine theta. So theta will be the inverse cosine of that. Of that, whatever this mess is here, there. What's the inverse cosine of that you had on your screen?
0.387.
Okay, that must be in radian mode. Okay, let's see what they were looking for. Yeah, 0.38. They got 0.3869, which is what you said, and in degree mode that would be 22.7. 0.3. What they say? They always get too many digits. 3869. Yours was better, or 22.17 degrees. Okay. And that looks reasonable here. This is 4,3, and this is vector 3,5, and that's a pretty small angle. Yeah, 22.7. 17. That makes sense. Good deal. I know this is the day you've been dreading all term, the last day of class, but otherwise get over it. For those who came in late, hang on, and I'll give you your old test. But for everybody, hang on, and I'll give you both the Chapter 3 test, and I'm pretty sure that I included on that everything we've covered so far. Yeah, because I didn't even get to dot products on it. So I'll give you the Chapter 3 test and the final exam. For those who came in late, I'll review this quickly. The Chapter 3 test is just covering, test, yeah. Chapter 6 test, it says test 3, but it's really your test 4, and that covers all five sections I think we had in Chapter 6. And then your final exam is, I think, 6 questions on Chapter 4, 2 on 5, and 2 on 6. Okay? So, I don't think you need graph paper, so here. Now, if you want to give these to me at 2 different times, that's fine. If you want to turn them both in at the same time, that's fine too. Okay? Okay. Please, folks, please do your student parts evaluations. If you haven't already, please don't forget to do that. All right.
I'll see you sometime next week.
Second?
I said I'll see you sometime next week.
Okay. To turn in the stuff, is that what you mean?
Yeah.
Okay. See you there. All right. Yes, sir.
Okay, so I'm just a little freezing right now, but I'll be right back.
Okay. Second?
I'll be right back.
I'm sorry?
I'll be right back.
Okay. All right. You want your previous stuff. Okay. Got to keep from losing.
I just need it'd just be the chap or the test 1 and 2, I guess.
Okay.
Because I just turned in the third one.
Okay. I'm having trouble. Yeah, that goes there, but what in the world does she have? Oh, I know what she did. Okay. That makes sense. Okay. Now, make sure I'm in the right stack. Okay, in it here. Okay. All right, it's getting close. Have you turned in research paper yet?
I emailed it to you.
You did, okay.
Yesterday. Or Tuesday.
Okay. All right. Ryan left already. Jemiah left. Cody. Lindsay didn't make it. Okay, Cerinthia's not here. Oh, gag. Let me pull this out. This is in the wrong place. This here. Well, I'll You just turned in your test 2?
Yeah, it's just turned in test.
Okay, here's your test 1. Somewhere here.
Can I turn in test 3 at a later date?
I don't remember. I've had so many turned in so many different days, I don't know.
Can we turn it in after today?
I need it today if possible.
Okay.
All right.
Also, can I receive the test? Did you give out a test today?
Oh, yeah. Oh, you were in here. Okay. Let me see where that is now. Here it is. Here's the final. Here's the chapter 6 test. That's really test 4. I didn't get it changed on the master. Okay.
So I missed 4. I think I forgot to just give you my sheet on this.
I wondered about it, but
Yeah, I think I just forgot to give you my sheet. So I just missed those 4.
yeah, I couldn't find them.
Okay. And that makes it a 73 with those.
Yeah. Yeah, if you could find the sheet, I'll regrade that. Okay, yes, sir. Then.
Let's just say questions is because I just had a realization.
I'm sorry, I can't hear you.
I just had a realization test three that I was missing some stuff. Like a couple of the answers are wrong.
Okay. My hearing is bad, so could you slow down just a little bit?
So the test 3,
Yeah.
I realized that I was doing a lot of the problems wrong,
Okay.
and I didn't realize it until today during class when I was going over it again.
Okay.
So I don't want to turn it in today because
Okay.
I know I would be a bad grade.
Okay. Well then, when can you get it to me?
Monday.
Monday? Oh yeah, Monday of next week. Huh?
Yes.
Okay. I thought you meant Monday of the following week. That would be, yeah.
No.
Yeah.
Monday
Okay.
of this-
That'll be fine. Yeah.
And then, based off your opinion, off my grades looking right now, will I be able to pass the class?
Well, so far it seems like you are. I don't think you failed anything, have you?
Well, I got a D. And I was
Well, that's passing. Okay.
my hardest
Okay, you got an 86 on your paper. That's passing.
79.
You got
on the
a
test one.
79 and a 60. So yeah, you're passing. You haven't failed anything yet. Yeah.
Okay, so I'm gonna tweak this one, and I'll be back on Monday.
Okay. All right.
That's all.
Now Monday I'll be in class pretty much from 10 till 4.
I'll be chasing you, so
Huh?
I'll find you.
Okay.
So
Well, I'm in here from 10 till 4, and I'm in the office from 8 to 10 and 4 to 6. Pretty much. I mean, I have to move around some. But so if you can either slide it under my door if I'm not in the office, or find me in the classroom.
okay, all right, thank you.
Okay.
Oh, and you're the only teacher teaching calculus during the summer, right?
Cal 1, yes. Yeah.
Yeah, that's what I need.
Well, no, I don't know. Is Miss Martin not teaching it? She's not. Okay. I couldn't remember. We did the schedule back, I
You
think.
did only one, which means that I'll have to start sticking with you after class, because
So good.
I'll have to start sticking with you after class.
Okay.
This entire semester, I've been struggling with everything.
Okay.
The trigonometric identities have just been beating me up. So
Okay.
I'll have to create a schedule with you for Cal 1 to start getting more help. And that's
Okay.
okay.
All righty. And there may be other help available too.
I
Because
tried that help. It didn't work.
okay.
So I think you're my best bet.
Okay. Well, it'd be a good idea to come to class soon.
Yes.
Okay.
That's it.
All right. Okay.
Oh, no, I gotta take my test. I gotta be to work at 12, but I told you I'd be back when I left my class.
Okay. Now have you
I hadn't
started?
started on it at all.
You haven't. This
No.
is test 2.
Right.
Okay.
I need to come
Do you
over to
need
the Birmingham
graphic?
campus tomorrow, too.
Do you need graph paper?
said we can use those like those formula sheets, Dr. Cloud.
I'm sorry, I can't hear
Let
you.
me show you, like this right here. Or the function, the thing that we was able to write functions on, I need what I need. I need this.
Okay.
Like the FOX and
Okay.
the standard form thing, you said you can use one of those? Like just to have something that has functions on, you got one?
I'm not, I can't understand what you're saying.
You know what I'm talking about?
My hearing's bad, I can't make out what you're saying.
Okay. Let's see. I can use this?
Oh, you can use a formula equation sheet?
Right.
Absolutely.
Okay.
Every test.
Okay.
Who was that?
I'm not sure who that was. That came in the house over there. I guess
Okay,
just
all
trying
right.
to see who was in.